We've seen rapid change in this industry over the last 5 to 10 years in terms of measurement, in terms of moving to multi-channel, really measuring audience behavior, especially digital millennials. Ad tech has changed, optimization has changed, content has changed. We've gone from segments to social, geo-targeting, personalization, lots of different things are going on. And it's important to really keep track of all of the most recent advances in the industry. And we are seeing exponential increases in complexity that can feel overwhelming at times. So we've gone from the experience of working on a 30-second video for over 6 months to 200 videos from Old Spice distributed over the internet in various ways in 48 hours, made and distributed in 48 hours. We've gone from a one-way message where the advertiser speaks to the consumer in one direction to a splintered real-time conversation with millions of consumers all at the same time through various types of media. We've gone from a single agency controlling the relationship between the brand and the consumer to, for instance, Kraft having 70 different advertising portfolio partners. And when I give that statistic, many times audience members will say, only 70, that's a small number. We have 200 or more portfolio partners to help us with our advertising. And this can feel a lot like a loss of control for the advertiser, because the advertiser's influence is decreasing while users or consumers' influence and voice in the conversation is increasing. Human decision-making is decreasing while automated decision-making throughout the process is increasing. And we're going from an experience of a single point of control of the advertising and marketing process online to an ecosystem where lots of different elements at the end of the day control what consumers see and how that affects consumers overall. But the good news is that there's a tremendous amount of opportunity ahead in understanding digital marketing and in understanding digital marketing analytics and optimization. I'm going to try to give you in this masterclass what I think are the most important lessons to know if you are a marketing manager or a chief marketing officer or anyone working in marketing today. The reason I think there's a tremendous amount of opportunity in this current landscape is because of what is known as Wanamaker's paradox. So Wanamaker famously said, and you may have heard this quote before, 50% of my ad budget is wasted. I just don't know which half. But the promise of today's digital marketing with all of the data and all of the analytics and optimization is that we can measure very precisely how people respond to ads, how people click, how people convert based on different ad copy, based on different ways of advertising. And now we can know very precisely what's working and what's not working. And we can use that ability to know what works and what doesn't work to make our marketing programs more effective and to optimize them. And so what I want to teach you today in a very short 45 minutes or so with time for questions is a process that I have designed that is geared towards doing exactly that. So I'll start with a story of Mark Pritchard, who is the Chief Brand Officer of Procter & Gamble. He's been there for decades, essentially their head marketer. And you know, that's a very large ad budget. Procter & Gamble is one of the largest digital advertising brands in the world. And he famously went to the Internet Advertising Bureau in, I think, 2016 or 2017 and said, you know, I am not pleased with the amount of click fraud, with the opacity or inability to really measure based on digital ads, you know, platforms. And he said, I'm cutting my digital marketing budget by $200 million. And the industry went really kind of crazy when he made this announcement. Wow, Procter & Gamble is going to cut digital marketing spend by $200 million. They can't do that. Their revenues are going to decrease tremendously. The entire business is going to contract if they're not spending money on digital marketing. $200 million is a lot of money. What's going to happen? The industry was up in arms. And then Mark grew sales by 7.5% while cutting digital marketing by $200 million. And he did that nearly doubling his own competitors and industries' averages for sales at the same time that he was cutting back on digital marketing. And this is a story that I tell in my book. The book is called 𝗏𝗏𝗏𝗏, and the 𝗏𝗏𝗏 really does describe in detail a lot of the principles that I'm going to briefly mention to you here. And this story is described in detail there. So how did Mark Pritchard do it? How did he cut digital marketing by 200 million and grow sales by 7.5% while nearly doubling industry averages? He did this by solving Wanamaker's paradox. He did it by becoming precise in terms of measurement and by making decisions in an optimization framework like the one I'm going to describe today. So what did he do? Well, he went from frequency to reach. So he started measuring the responses to frequent ads, the same consumer or user being hit with multiple ads at a time, versus the efficiency of reaching new audiences. And he reduced the frequency of advertising to the same consumer multiple times by 10% and increased the reach to new consumers, mainly in China, but elsewhere, by up to 60%. So increased the number of new people that he had never advertised to before by about 60%. He also really focused on the precision of targeting. So he went from coarse demographics, 20 to 30-year-old women, to much more fine-grained, smart audiences like first-time moms or first-time washing machine owners. Those types of very fine-grained targeting really helped him succeed and make his digital marketing precise. And he doubled down during COVID and increased digital marketing because everyone was online. So he essentially solved Wanamaker's paradox. And I want to give you a sense for how detailed the things that you can do are. I was at the New York Times as the scholar in residence during my last sabbatical. And at the time that they were rolling out their paywall, and I helped them design their paywall and to measure the effect of their paywall on revenues and subscriptions, just to give you a sense for how much data, what you can really measure in terms of web traffic and how different marketing and subscription models are working or not working. So we collected data on about 200 million users, about 1 billion page views, and had data on a pre and a post period where they implemented one version of the paywall. In the pre, there was no paywall, and in the post, there was a specific version of the paywall. And what we could see was, for example, impacts on the number of articles that were being read. So in the top line, that dark line, you see the subscribe users. And in the thin gray line at the bottom, you see non-subscribers, people who are visiting the New York Times but are not subscribed to the newspaper. And what you see when they implement the paywall is that the level of reading of the subscriber stays the same in that top bar at the top. But the level of reading, the number of articles read by non-subscribers, drops off dramatically, and you can measure exactly how much it drops off. And this obviously reduces advertising revenue because fewer people are reading as many articles, and so you have less advertising inventory and thus to sell, and thus less ad revenue. But we could also measure with precision how this little experiment increased the number of subscriptions. So there you see the blue line is the number of subscriptions going up in the post period once the paywall was implemented. And what you can then do is you can calculate the net revenue impact of the revenue increase from the increase in subscriptions and the revenue decrease in the advertising revenue and the impressions. and you can actually determine what the net impact on revenue was. And we saw that for this very short period, just a few months, 6 months, it had millions of dollars net positive impact on the New York Times bottom line. And because of that, they rolled out finer grained and more site-wide examples of the paywall, which essentially saved their business. I'll give you another example. I was watching this commercial on television one day, and I'll show you the commercial, and then I will tell you what happened. This is a commercial for Jet.com, which was a competitor to Walmart, and this is a commercial describing their quote-unquote price slasher robot. So here's the commercial. Hopefully you can hear it as well. Please do stop me if you can't hear it. So in case you couldn't hear it, I'll describe what's happening. The guy is putting items in his cart, and he's saying, as I put items in my Jet.com shopping cart, the price slasher robot slashes the prices of other items in the store. And so at the time, my former student, Jack Hanlon, was the head of analytics at Jet.com. And so I called Jack and I said, Jack, I saw your great price slasher robot. Very cool, very interesting. Just had a question for you. How do you decide what items to slash the price of in the store? And he said, Sinan, I'm embarrassed to say that we slash the price of the items closest to the item that you put in the cart in the warehouse. So whatever is next to that item in the warehouse, we slash the price of that, because it's easier for our warehouse workers to put two items that are close to each other in the warehouse in the same box and ship it to the consumer. We don't want them to walk all the way around to the other part of the very large warehouse to find some other item to bag together. It would create too much logistical inefficiency. And I said, Jack, you know, you're leaving hundreds of millions of dollars on the table because you're not optimizing your bundles and your prices for demand maximization. I said, let's do an experiment where we measure what are the optimal products to bundle together and what are the optimal prices of those bundles. Let's create those bundles. Let's find the optimal price, and then let's put those items next to each other in the warehouse to also capture the logistical efficiency that you want to capture at the same time. So that's exactly what we did. We entered into a project where we learned that kind of information from a series of large online experiments. And the way that these experiments worked was that we found complementarity and substitutability between products by running a machine learning algorithm over all of the clickstream data as people were shopping online. And the key insight was that items that are searched together but then don't make it to the checkout page together are substitutes. For instance, I may search for ground coffee. I may see in the search results 3 different brands of ground coffee, and I may pick one of those to purchase. I may then search for milk and cookies, and if I find milk and cookies and both the milk and the cookies make it to the checkout and get purchased together, those are likely to be complements. And so we found substitutes and complements through this machine learning task. Then we created optimal bundles. We experimented with different prices to find the best price. And then we applied all of this knowledge back to the 90,000 SKUs through a transfer learning method that learned what the optimal bundles and prices were, and then rearranged the warehouse based on that. So we found these learning complements and substitutes across different categories and across different prices. Some were more complementary, some were more substitutive. On the right, you see substitution scores. On the left, you see complement scores. And we applied this 90,000 to the 90,000 SKUs online. And then we aggregated this to their entire inventory across all of their different online shopping areas, like pantry items or personal care or pet supplies, skincare, and so on and so forth. Now, the key lesson that underlies the entire process I'm about to describe to you, which is the integrated digital marketing framework and the optimization framework, is the idea that causal inference or causality is the most important thing that any marketer must know and understand to be effective in today's marketing environment. So here's a cartoon that I have on my office door. It's two friends talking, and one friend says to the other, "I used to think correlation implied causation. Then I took a statistics class and now I don't." And the friend says, "Oh, it sounds like the class helped." And the other guy says, "Well, maybe." And the reason that's funny is because it may be that the statistics class taught him about the difference between correlation and causation, but there could be other reasons for this. For example, somebody who knows the difference between correlation and causation, something very nuanced about statistics, might be more likely to take a statistics class than someone who doesn't. That's called a selection effect or a selection bias. And this is notorious for messing up our measures of ROI in digital marketing, not having causal estimates of the effect of our advertising on consumer behavior, ruins the entire process of measurement. And that is the core lesson that runs this entire framework. So what is the integrated digital marketing framework? It's quite simple. You first develop on the left-hand side a strategy that you want to accomplish certain goals with certain behavioral changes and consumers that you want to see. That strategy leads to the creation of content, ad copy, videos, blog posts, Facebook posts, tweets, advertisements of various kinds, and so on. And then that content is deployed over a number of different channels. For example, display advertising or search advertising or social advertising or mobile advertising. And there could be other channels, influencers, and so on. I'm just listing 4 channels here, but there could be any number of channels there. And there are 2 elements of optimization that happen. One is within channel optimization. So within any channel, say display or search, you have an advertising program of display ads or search ads. And you are constantly measuring the return on investment from each of those ads, and then allocating budget to high performing ads, and then less budget to low performing ads, and eventually getting rid of non-performing ads, and then continuously adding new ads into the channel. So you're optimizing the ROI within the channel by allocating dollars to ads that work better, allocating dollars away from ads that work not as well, and constantly reintroducing new ads into the channel. The second bit of optimization is the across-channel optimization. So for instance, if your search advertising has a high ROI and your display advertising has a low ROI, then you allocate resources towards the best performing channels and away from the least performing channels. And you are constantly measuring this day to day, week to week, and month to month, and allocating dollars towards high performing channels and content within channels, and away from low performing content within channels and channels that aren't performing. For instance, if you have search advertising that isn't performing well, you channel dollars away from that search advertising and towards other channels that are performing well, but then you try to fix what's going on inside your search advertising program by increasing the ROI of your search advertising, trying to pick the right search ads, changing your quality score, and so on and so forth. As the ROI in search increases, you start allocating dollars back into search and away from other things that are not performing as well. So this dual optimization within channel and across channel optimization is what drives the framework in this integrated marketing framework, which, by the way, I describe in detail in my book, The Hype Machine. There's also a second part of this framework, which is the marketing analytics and optimization framework. And let me describe to you how that works now. So on one hand, you have market conditions and marketing actions and competitor activities, as inputs to this process. I'm going to show you the entire process, and then I'm going to work backwards for how the optimization works. So you have some market conditions in which you're operating, your competitors are doing certain things, and then you choose certain marketing actions. Allocation of budget to certain channels, allocation of budget to certain ads within those channels, and those are your marketing actions. It could also be, organic things like Facebook posts or inbound marketing or influencer dollars. You go through a process, and the last step of this process is to deploy the advertising. Now I'm going to show you what happens, and I'm going to go back to the first step, but let me start with the end. Once you deploy a series of ads across channels, that's going to create some consumer responses, which you can measure. That's going to be clicks, conversions, video view-throughs, hovers, and so on. Those consumer responses are going to create some business outcomes, increases in revenue, increases in sales, and so on. You're going to measure consumer responses and business outcomes, and you're going to attribute those types of responses to your marketing. And based on what's working, what's not working, both in terms of business outcomes and consumer responses, you're going to then in the next round change your marketing actions. So you see what happens, and then you adjust what you're doing, both within and across channels. In order to do that, you have to go through a number of steps. The steps are, first, when you see the consumer responses and business outcomes, you have to go through a process of attribution. You have to attribute those changes in consumer behavior and business outcomes to your marketing actions. That includes attribution modeling and as well causal inference. And in terms of causal inference, you have to determine what the causal effect of your marketing is on consumer behavior and business outcomes. Once you have attributed the behavior and the outcomes to your marketing through causal inference, then you optimize. You measure ROI rigorously, and then you optimize based on that ROI. The way you optimize is through allocation, which is the third step. You allocate budget to different channels and different ads or marketing actions within the channels based on your ROI measurement and optimization, which is itself based on your attribution modeling. And then once you've allocated, then you deploy. And deployment involves targeting the ads at the right people and delivering the ads. That creates consumer responses and business outcomes, which then go into changing your marketing actions. That's your within and across channel optimization of which ads to show and where to put the dollars into which channel. Then attribution, ROI measurement and optimization, budget allocation, targeting and deployment, and then you do it all again. So it is a repeatable process, both in terms of marketing analytics and optimization that I've just described, and in terms of this integrated digital marketing framework with it, which is within channel and across channel optimization. So if you think about how digital ads are bought and sold today, it kind of works like this. The consumer visits a website or a mobile app or a mobile browser website. And the first thing that happens is cookies are exchanged. There's also zero-party and first-party data as cookies are becoming less and less prevalent as Apple increases its privacy protections and so on. Just hold that aside for a minute. Then there's a direct sale of premium placement ads directly to the advertisers, after which pieces of inventory are made available for auction from the publisher, first to an ad network, which aggregates and sells blocks of ads directly to advertisers. And then those ad networks make the rest of the inventory available to supply-side platforms like Rubicon. Any remaining inventory is made available to these supply-side platforms directly from the publisher, for instance, like the New York Times, who's selling the advertising spaces. And this supply-side platform provides real-time bidding and yield management processes on the publisher side. Makes those ad slots available to an ad exchange like DoubleClick. Facebook runs its own ad exchange. And then the advertisers make the ads available that will go into those ad slot inventory first through things like trading desks like Acuin, which then make the ad copy or ads available to a demand-side platform like Rocket Fuel. And the demand-side platform provides real-time bidding and budget pacing for the advertiser side. They also provide ads directly to the demand-side platform. And then the ad exchange, this side, by the way, the provision of the ad copy is many times controlled by an agency like 𝗶𝘃 or Omnicom. Then the exchange offers ad inventory to the demand side as offers. It says, hey, I have this slot on the New York Times at 9 a.m. with this particular consumer. And the advertisers, through their demand side platform or their agency, bid on those inventory slots. And then once somebody wins the bid, the ad is served. And this entire process that I've just demarcated in the green dotted line is called real-time bidding. All of this happens in about 10 milliseconds. That entire real-time bidding process is supported by a data layer of data management platforms and third-party data providers that enable targeting, bidding, offers, interactions with the ad exchange, and so on. What ad networks do is they aggregate ad inventory across multiple sites to achieve scale and reach. They forecast inventory across publisher sites in advance, like a month in advance. And then they do deals with advertisers to sell that inventory, usually in advance. There are a bunch of different types of these types of ad networks, like rep networks that represent select publishers, like the Condé Nast family of websites, often exclusively as an ad outsourcer for those publishers. Vertical ad networks that represent publisher sectors like sports or fashion, and then targeted ad networks that sell specific audience segments that are based on demographics or behavioral audience segments. The ad exchange, that real-time bidding auction process, happens like this. So on the right-hand side, or I guess your right-hand side, you see the consumer on the website interacting. When the visitor hits the publisher URL, the publisher sends a request to the ad exchange for one ad of a certain type, like a banner ad. That happens at 0 milliseconds. The ad exchange then publishes the details of that impression, who it is, what website it's on, what ad unit, and any cookie data or information about that visitor makes them available at about 2 milliseconds. Then the advertisers, usually through the demand side platform, bid on that ad impression. They respond with their bids based on the value to them at about 5 milliseconds. And then there's a ad exchange selects the highest bidder and sends the creative to the website at about 7 milliseconds. And then the ad is served within about 10 milliseconds. So pricing is a really important part of this. So if you're an advertiser, you kind of want these things priced a certain way. And if you are the publisher, you kind of want them priced a different way. So for instance, if you are a publisher, you kind of want them priced per mille or per 1,000, because you're sort of saying to yourself, it's not my job to make good advertisements that perform well. That's your job. And so I would rather them price CPM. Whereas CPC is cost per click, where the publisher only gets paid if a user clicks on the ad. That's more performance-based pricing, and more even performance-based pricing is cost per action, like a cost per conversion. That's even more intensely performance-based. And so if you're the advertiser, you really want them based on performance, like cost per click or cost per action. And if you're a publisher, you kind of want them priced based on CPM. Now, a big part of this process is ad targeting. And the way ad targeting works is you want to model, for instance, the probability of a click or conversion as a function of a number of different things. And so on the left-hand side, you have the probability of a click or conversion. And on the right-hand side, you want this probability modeled as the function of a lot of different things, like demographic features of the audience, or behavioral features like knowing what they've clicked on in the past or what their interests are, or social network features, who their friends are and what they've bought in the past, or location-based features like where their mobile phone is today, or how often they are, at the beach, or in the Mercedes dealership parking lot. And the way you evaluate these targeting models is by two main criteria, precision and recall, where the precision is the fraction of predictions that the model says are relevant that are actually relevant. So for instance, if I'm trying to identify high likelihood customers, then precision would be the high likelihood customers identified by the model over the total number of consumers that are identified. That's the precision of the model. And then the recall of the model is the fraction of relevant instances identified by the model. So that would be the high likelihood customers identified by the model over the total number of high likelihood customers out there in the world. How many of the high likelihood customers do I find? That's recall. How many of the ones that I suggest are high likelihood that are actually high likelihood? That's precision. Use precision and recall to create what's known as the AUC curve, the area under the ROC curve. And what AUC is a typical measure of the performance of a model like this. AUC is an acronym you'll see all over the industry. Basically, it is, roughly speaking, a measure of the rate of false positives and the rate of true positives. So here I have 4 different models, method 1, 2, 3, and 4, black, red, green, and blue. And what you see is method 1, for a 20% false positive rate, gets you a true positive rate of about 20%. But for the same 20% false positive rate, method 2 gets you a true positive rate of about 30%. And for the same 20% false positive rate, method 3 gets you a true positive rate of about 70%. And method 4, for the 20% true false positive rate, gets you a true positive rate of about 90%. So the area under each one of these curves is, the greater that area, the better performing the model in terms of false versus true positive rates in terms of identification. So the average click-through rate for a display ad is about 0.05%, which means you have to be very precise in your targeting and your measurement. And let me give you an example, which is called retargeting. If you have ever browsed an item, left the site, and then seen an ad for that item follow you all around the web, this is called retargeting, and it's kind of creepy. The way retargeting works is that 2% of site visitors purchase on the first visit, and retargeting targets the 98% who leave with ads that bring them back. So a visitor visits the site, they learn about the products before and leave without purchasing, and the retargeting firm displays the ads on the site later, bringing them back. And the retargeting firm places cookies on the visitor's browser and works with the ad exchange to place the ads where the visitor goes next all over the web. And retargeting is said to perform extremely well. So a 0.7% click-through rate compared to a 0.05 or 0.07% click-through rate for display ads in general. 1,046% quote lift in brand search activity, or a 400% quote lift in ad response. But the reason I put lift in quotation marks is the main lesson of this entire masterclass, which is correlation versus causation. Retargeting targets people who are already interested in buying that product. They just haven't bought it yet. And that means that if you give yourself 100% credit for advertising to that person, you are overestimating how good your advertising is by a significant fraction. So let me give you an example. The typical equation for measuring return on investment is as follows. This is one that you'll see in an investment textbook. ROI, or return on investment, is the benefit from the encouraged behavior minus the investment itself divided by the investment to make it a percentage. That's ROI. That's a very typical way of measuring ROI. You can find that anywhere on the web or in any textbook. But here's the problem with measuring ROI this way. Imagine that you spend $51 million a year on advertising, and measuring ROI this way, you think you have a 4,100% ROI on this $51 million a year investment. But when you measure ROI correctly, separating correlation from causation, you find that your ROI is actually negative 63%. This is exactly what happened to eBay in a real experiment using the methods that I'm describing here. By correcting their mistakes in measuring ROI. What happened? Well, let's put it this way. Let's say that as you were walking into either the virtual classroom today or the auditorium that you're sitting in today, I was standing at the door handing out flyers advertising this class as you walked in to take it. What is the conversion rate of that ad? How many people who I gave the ad to took the class? Well, that's obviously 100%. Everyone I handed an advertisement to took the class. So the conversion rate on my ad is 100%. Now I ask you a different question. What is the actual behavioral change? What is the causal lift created by this ad? It's zero, because you were all already going to take this class when I handed you the ad. So if I target people with an ad, if I target people who are already likely to take this class or who are already walking into the class, and I say that 100% of my ads worked, I am obviously overestimating the effect of my advertising. And that's what the majority of brands are getting wrong today. So when eBay did an experiment and they took their search advertising on the left for Microsoft Bing and on the right for Google, and they stopped their ads, their search ads, what they showed was all of the traffic just went to organic. So in the dotted red line, you see organic traffic. In the blue line, you see paid search ad traffic. And what you see is they cut their paid search ads, and all of the same people came to their website. They just came through organic search, which means the ads that they were paying for weren't causing any of this behavior to begin with. What they did find, however, is that on the left, user frequency, and on the right, user recency, that if you had, on the left, you see users purchase count for the 12 months, for the last 12 months. If you had purchased 0 products from eBay or 1 or 2, the ads helped. For everyone else, the ads were a waste of money. And on the right-hand side, you see that if your purchase at eBay was at least 360 days ago or more, the ads helped. But for everyone else, the ads were a waste. They were just correlation. They weren't causing any behavior change at all. So by doing causal inference, in this case, a randomized experiment, you can see and attribute what's actually working and what's not working. So the real way to measure ROI is not ROI is equal to the benefit from the encouraged behavior minus the investment divided by the investment to make it a percentage. You have to add another term, which I call lift. And what lift is the fraction of the benefit that you can actually causally attribute to your ad. What fraction of the people that bought the shoes were caused to buy the shoes by the advertisement? That's attribution. And if you scale down the benefit by multiplying it by that lift number, that lift ranges from 0 to 1. So maybe 90% of the purchases were actually caused by the ads, or maybe only 10% of the purchases were caused by the ads, and 90% would have bought the shoes anyway. Then you get a real measure of your ROI, and that little trick of focusing your ROI on causality is what Mark Pritchard uses and what many other people who are really good at this use to optimize ROI. I'm going to skip this for a minute. actually, let me just describe this briefly. That gives us 3 regions of ROI that matter. So here we have a gross profit curve in blue. In red, we have the 45-degree line. And then in the black line, we have the tangent to the gross profit curve. So there you see C star, the first C to the farthest left, that dotted line. That is the optimal level of advertising based on gross profit. If you go to the right of that, your ROI is positive, but you're spending too much on digital advertising. You could cut back on digital advertising until you got to C star, which is the optimal amount to invest. If you are spending more beyond to the right of CH, where the blue line crosses the red line, then ROI is negative. If you are less than C star, but the blue line is still above the red line, your ROI is still positive, but you could be spending more to be optimal. So you can, once you've got the causal ROI framework down and you've got the integrated digital marketing framework down and the optimization process down, you can get a precise amount for how much you should be spending on advertising in terms of the investment to optimize return on investment based here on gross profit. Attribution, the customer takes a long journey. They might see an ad impression, make a direct visit, not buy, leave, then be retargeted, not be clicking through on the retargeting, but that might cause a branded search. After the branded search, they may convert. You can attribute this in a bunch of ways. One way is last touch. Give all the credit to the last advertising touch. Another way is first touch. Give all the credit to the first ad impression. Another way is linear. Give an equal amount of credit to every touch along the way. There's also time decay, so last touch and then decaying in time backwards, or position-based, where I want to give the most attribution to first or last touch, or algorithmic, where you have an algorithm that assigns credit across the board. The key to all of this is consistent causal ROI measurement based on and embedded within the integrated digital marketing framework and the optimization process. And I'll say one last thing, which is to say that the best way to causally measure the effect of advertising is randomized experimentation. That is the gold standard of causal inference. That's A/B testing, multivariate testing, some sort of randomized experiment. If you cannot do randomized experiments to accurately measure ROI, there are next best alternatives. There are causal statistical methods that get you part of the way there, like surrogate models or propensity score matching or instrumental variables or some other type of matching estimator. So just to summarize a few key lessons from today. One is you have to have an integrated digital marketing framework where the key is to optimize within and across channels. Second, you have to have an optimization process that focuses on attribution and causal modeling, followed by rigorous ROI measurement in the way that I described, followed by optimization, followed by deployment, which includes that targeting model and how to measure it. Third is accurate and appropriate ROI measurement. Measuring ROI and basing all of your optimization on ROI is the key. The key to measuring ROI appropriately is to have that lift part of ROI inserted and to measure lift through randomized experimentation or other causal inference methods. So, bit of a whirlwind tour. Hope it was helpful. Thanks.